Most of what you think you know about science is built on confidence, not certainty. And history shows a disturbing pattern. The ideas we laugh at the hardest are often the ones that end up rewriting reality itself. For centuries, some of the most important truths in science were not just ignored, they were actively ridiculed, buried, or punished. And yet, they kept coming back until the evidence became impossible to deny. What follows are not just discoveries. They are moments when human certainty collapsed in front of reality. In the early 1600s, a group of English settlers arrived in Jamestown, Virginia, chasing a dream of a new world. Instead, they walked into a silent catastrophe. Supplies were delayed, crops failed, and alliances with local tribes collapsed. As winter set in, starvation began to erase the boundaries of civilization. Horses disappeared first, then dogs, then anything that could be chewed. But when even that was gone, something unthinkable happened. Survivors later described a descent into cannibalism so extreme that it crossed into moral collapse. One account spoke of a man who killed and preserved his own wife to survive. For centuries, historians dismissed these stories as exaggeration, propaganda, or colonial myth-making. It was easier to believe that humans wouldn't fall that far. Then, in modern archaeological digs, evidence began to surface that matched those horrifying accounts with chilling precision. Human remains showed cut marks consistent with butchery, not burial. The line between myth and survival horror suddenly disappeared, and the past became far harder to sanitize. For a long time, the ocean was thought to be predictable, almost mathematical in its behavior. Waves followed patterns. Storms could be modeled. Ships were lost only when humans miscalculated. But sailors kept reporting something that science refused to accept. Walls of water appearing without warning in calm seas, towering far beyond anything standard models allowed. These were dismissed as superstition, the exaggerations of frightened crews. Then modern instruments began to tell a different story. Offshore platforms recorded sudden, isolated waves rising to heights that should not have been statistically possible. In controlled measurements, these impossible waves appeared again and again, revealing a hidden instability in the ocean itself. It turned out the sea was not a smooth system at all, but a chaotic field where energy could suddenly concentrate into destruction without warning. On land, another mystery was buried deep in stone. For decades, scientists argued over what killed the dinosaurs: gradual climate shifts, volcanic eruptions, slow extinction over time, anything but catastrophe. Then a strange chemical signature appeared in rock layers around the world, a thin line rich in iridium, a metal rare on Earth but common in space. At first, the idea seemed absurd. A cosmic impact strong enough to reset life itself sounded like science fiction. But then a massive crater was discovered beneath the surface of Mexico, perfectly dated to the same extinction period. The scale of destruction became undeniable. An object from space had struck Earth with such force that it triggered global firestorms, blocked sunlight, and collapsed entire ecosystems. What once sounded like fantasy became one of the most important turning points in Earth's history. Even the structure of the Earth itself was once misunderstood. Scientists believed continents were fixed, immovable foundations of the planet. Maps were stable because the world was stable. But one scientist noticed something strange. Coastlines seemed to align across oceans as if continents were pieces of a broken object. He proposed that the Earth's surface was not static at all, but slowly drifting over time. The idea was mocked so harshly that it became a symbol of scientific failure. Critics demanded a mechanism he could not fully explain at the time, and that absence was enough to dismiss the entire theory. Decades later, mapping of the ocean floor revealed massive underwater mountain chains and spreading zones where new crust was forming. The Earth was not still. It was alive in motion, reshaping itself slowly but constantly. In the early 20th century, even the universe itself was assumed to be eternal, static, unchanging, a fixed backdrop to existence. Then a new interpretation of cosmic expansion suggested something far more radical. If the universe was expanding, then running time backward meant everything converging into a single origin point. The idea was uncomfortable, almost philosophical, and many rejected it for sounding too close to religious creation stories. But years later, a faint signal was detected in every direction of space, a leftover echo of heat and radiation from an ancient beginning. It was not theory anymore, it was observation. The universe had a starting point, whether humanity was ready for it or not. Inside biology, another assumption quietly collapsed. Genes were thought to be stable instructions passed down like fixed lines of code. But while studying maize plants, a researcher noticed something strange. Genetic traits were not fixed. They were moving, shifting position, turning other genes on and off in unpredictable ways. The idea that genetic material could physically relocate inside a genome sounded impossible at the time. It broke the simplicity of inheritance, so it was ignored for years, even decades, until molecular tools finally revealed that large portions of DNA were not fixed at all, but mobile, shaping evolution in ways no one had predicted. What looked like an error in observation turned out to be a hidden engine of life itself. Even inside the human body, identity is not what it seems. For a long time, cells were believed to be purely human in origin, functioning as a unified biological system. But deeper analysis revealed something unexpected. Tiny structures inside cells carried their own genetic material, separate from the nucleus. They behaved independently, replicated on their own schedule, and resembled ancient bacteria more than human components. The conclusion was unsettling. Complex life may have originated from an ancient partnership between organisms, a merger so old it became invisible. Life, it turns out, may not be singular at all, but collaborative at its deepest level. Some discoveries were not just rejected intellectually, but personally dangerous to those who proposed them. In medicine, doctors once believed stomach ulcers were caused by stress and lifestyle. Patients were told to manage anxiety, avoid spicy food, and accept chronic pain as part of life. Then a strange observation appeared. A bacterium was found living in the stomach, an environment previously considered too acidic for any life. The idea that infection, not emotion, was responsible challenged everything. To prove it, a researcher deliberately infected himself. His own body became the experiment. When disease followed and antibiotics cured it, belief finally began to shift, but only after years of resistance. And perhaps the most disturbing pattern of all comes from medicine itself. In the 1800s, hospitals were deadly places. Women giving birth were far more likely to die in medical wards than anywhere else. One physician noticed a terrifying pattern. Doctors performing autopsies were moving directly from corpses to patients without cleaning their hands. He proposed a simple intervention: disinfection. The results were immediate. Death rates collapsed. But instead of acceptance, he faced outrage. The implication was too offensive. That respected professionals were causing death through ignorance. The idea was rejected so strongly that the man behind it was eventually isolated, dismissed, and broken by the very system he tried to save. What ties all of these stories together is not just science, but human psychology. We assume certainty where there is only habit. We defend consensus even when evidence begins to crack it. And again, truth does not arrive through agreement, but through persistence against resistance. The uncomfortable question is not what science has gotten wrong in the past. It is what we are confidently dismissing right now that future generations will find obvious, because history does not remember how loudly ideas were rejected. It remembers how quietly they turned out to be true.